Hello all, today in this video I am going to provide details regarding and demo video for RNN with an optimizer. This is a continuation of previous video only. We have made some previous video with the different optimizers, and in this work with the different optimizer, and we are going to make a comparison of all the optimizers we have made. So for that we are importing the libraries which we are needed, and then we are loading the heart disease dataset dataset which we downloaded from Kaggle. You can just give us heart disease prediction dataset. Kaggle means you will just get this dataset. The data set which we are using is having nearly 14 entries. Among that, the first 13 entries we will be using as the X variable, and the last entry, which is the target one, we will be using as the Y variable. Then we are getting the info of the data set. Previously, by seeing the data set itself, you can notice that it is having only integer and float type values. Also, we are getting, so from that you may notice that the old peak is the only one which is the float type, and all others are integers. And then we are checking our data set is having any null entries. You may notice that since every data is or features is showing 0, it is not having any null entries. Then we are displaying the heat map of the data set. So this is the heat map of the data set. Then we are just determining the X variable and the Y variable. As I said previously, within the X variable we are dropping the target variable, and for all others come under the X variable. Within the Y variable we are using only the target variable. Then by the use of this X variable and Y variable and the train test split function, and the test size as 0.2, that is 20% for testing and remaining 80% for training, we are determining variables like X train, X test, Y train and Y test. Then we need some vectors within the X variable. So we are using the standard scalar to convert the train variables to vectors X train and X test. And then we are getting the shape of X train. Why? Because this RNN will work with only three-dimensional data, but our data is two-dimensional. You may notice that it is only two-dimensional. So we have to reshape our data. So we are using the reshape function, and by this we have reshaped the data. This input data shape only we are using within the simple RNN layer, within the layer contribution, and the activation as ReLU. So this is the layer contribution of RNN. Then this is just a simple RNN. Then the dense layer, since binary classification work, we are using 1 as the output dimension. If it is multi-class means it will be replaced by the number of classes we are having. So mostly in binary classification work, we will be using the activation as sigmoid. Then we are getting the summary of the layer contribution. So this is the summary of the layer contribution. Then we are compiling our model by the laws, optimizer and metrics. Here you may notice the optimizer is Adam, and then we are fitting our model, training our model by using the fit function, and the variables like X train, Y train, X test, Y test, and it is a train for nearly 50 approaches. You may notice that for 50 approaches we have got the loss accuracy, validation loss and validation accuracy. Then we are displayed the classification report for Adam optimizer with values like precision, recall, F1 score and support. Then this is the confusion matrix definition, and then we are plotting the confusion matrix for the Adam optimizer. Then we worked with the SGD optimizer. The only difference within every optimizer is that the layer composition, everything and all same, but the only place that is the optimizer. Here previously if you notice means it will be Adam, now it is SGD, all others are same. We are displaying the classification report and confusion matrix. Then we worked with the rmsprop. So we replaced the optimizer in place of optimizer as rmsprop, and got the approaches to run for nearly 50 approaches, and got the classification report and also the confusion matrix. Now We have also worked with adadelta. Here you may notice. So we have replaced the optimizer as adadelta. Then we have displayed the classification report and also the confusion matrix. So you may notice we have made a comparison chart for every uh, uh, parameters like loss, validation loss, accuracy and validation accuracy. For that, each color is going to represent each optimizer's training accuracy and validation accuracy. If you notice this blue color, which is training accuracy of Adam, and mostly this Adam and this rmsprop is more or less merging with one another, and it is high. SGD, this one, it is within the middle, and last one, that is now which we have made adadelta, it is showing some less percent accuracy only, and it is down. When comparing to loss, it is high, because since the accuracy is low, loss will increase. So this is the details for adadelta algorithm optimizer with RNN. In the next video, we will be working with adagrad optimizer, and will make the comparison here by improving adadet. Thank you.